Yes, we're live. Hello, everyone. Trends in AI December 2024.
End of year edition. It's the last one for this year. Thanks for joining here live in Lab 42. And thanks for joining online on Zoom, YouTube, LinkedIn. And thanks for joining also from the US. Good morning over there. My name is Jakub Savrel. I'm the founder of Zeta Alpha and hosting Trends in AI by Zeta Alpha together with Dinos.
Yeah, hi, everyone. My name is Dinos. I'm an AI researcher here at Z Alpha and your usual host. This episode of the webinar is a bit different because it's the final one for the year. So we have also prepared a little throwback, have a look at our predictions and see how we did, and also reflect and look forward as well.
It's already a full year, and in January we made some wild predictions. Well, not so wild. So let's see how we have done. And what else do we have for this special edition?
Well, we have the regular papers, a lot of papers actually, and model releases, which I'm really looking forward for. And next week is actually NeurIPS, one of the biggest, if not the most prestigious conference in AI. So we'll also dabble a bit in which papers are popular now, which we'll have already covered, and which ones people should pay attention to if they are in Vancouver this next week.
And we have some people in the audience who are going, actually. Shout out for them. So let's dive right in. So when we are looking back, I think it's also good to say happy birthday, second birthday to ChatGPT, which was last week, right?
Yeah, November 30th, 2022.
Yeah. So I think it's been quite the ride. I think just in time, they have actually arranged for a some kind of successor, right?
Well, we'll see. A bit in sneak preview or actually full release yesterday, but I don't think everyone has let it settle and what it means for the continuation of ChatGPT. But for sure, the current product as it is has evolved a lot over the 2 years. We started with 3.5, we got 4, 4.0, and now 0.1 finally officially released, but more on that in a minute.
And just last week, also a new update for 4.0, right? It was quite a good update.
Right. I think they targeted more creative writing and the layman's use of ChatGPT to not be only good at coding, but also to, I think, cut their losses to what Anthropic does with Claude. Because now I feel like everyone goes to Claude when they want to have a more creative or poetic or not so AI hearing words like delve and certainty.
Yeah. And there's been also, as usual, the speculation about what OpenAI is going to do. Until recently, the wildest speculation was ad-supported ChatGPT. But now, I think since a few days, there's a completely new twist to the story. The kind of advent calendar of OpenAI, where they promised 12 releases or 12 announcements in 12 days. And the first one dropped yesterday in the evening, is the new 0.1 model. Well, we had 0.1 preview, right?
Right. Yeah, it's 0.1 full release, which on benchmarks, it does similarly to preview in some aspects, like which one is this? Yeah, the GPQA benchmark, but in others like coding or math, it is quite substantially improved.
Yeah, I think the claim is especially on math and kind of hard puzzle-like science problems. The other main advantage seems to be that it's a lot faster, that the kind of thinking time is more variable. So on easy question, it answers very quickly. A hard question, it takes a lot of time to think. And if you pay 10 times more, $200 per month, that's the new subscription, then it will think forever until it finds the solution.
Have you tried it?
I did not pay that amount. No, I did try it, and I was a bit underwhelmed actually on most of the things that I had tried 0.1 preview before. It was kind of similar, maybe a little bit faster. So
All this was just day one. I can't imagine what they have for the last 11 working days of the year, they said.
this should not be the best of them. What was interesting is that they also released this system card, which was mainly focused on security testing, right? It had a little bit of benchmarking, but mostly on kind of the results from the red team security testing. There was this kind of funny little detail that in 5% of the cases, when it was tested by security researchers, it had actually tried to change the system settings so that the oversight would be disabled, or actually transfer its weights to some other system. It was kind of more a role play thing. But certainly if you talk about like alignment, it was trying to do sneaky stuff behind the scenes. So
yeah, and we've seen in the past how difficult it is, for example, to prevent it acting in a harmful way, because if you train it to avoid it, then someone might flip it with some very clever prompts. So
there's always some kind of adversarial attack possible. And the biggest adversarial attack on OpenAI might be actually signaled in this tweet here. Sam Altman very neutrally gave his congratulations to David Sachs, who was yesterday appointed the new AI and crypto Tsar, as they call it in the US. So the main government official responsible for regulating AI. And well, he's a friend of Elon Musk and one of the hosts of the All In podcast. And in general has been very much touting the Republican sort of free speech absolutism agenda. So I'm really curious what that means for AI regulation in the US. What do you think?
Well, I think, the general trend is that they want to, obviously, this whole lobbying has helped them. It's kind of in their field now, where AI has to develop and compete with state actors in China and Russia, maybe. So I think in general, they will be in a very advantageous position now.
Yeah, at the same time, I think the focus is on regulating sort of more applications rather than the foundational model research itself, right? So I think we might see the US AI regulation aligning more with European harmful application areas rather than the pure raw compute regulation, which was kind of thanks.
Sound is not it's not in a webinar.
Do we have good audio? Maybe not. Let me. Can you continue?
Yeah.
I'll try to fix that.
Right. So this is what we have on OpenAI. But yeah, let's have actually a look back into what we predicted that would happen for this year in the general AI scene. Our first and most easy guess prediction was OpenAI will respond to the array of attacks that they were getting in the beginning of the year. So let's go back 1 year. I think it was right as Gemini had dropped. So our first prediction was, they're not going to let that happen. So our prediction was GPT 4.5 or even GPT 5, which did not happen. So, but instead we got 4.0, and I would say this is probably just as good, if not better, than just scaling the model. What do you think?
Well, we still have the 12 days coming ahead. So there's certainly a lot of speculation about GPT 4.5 still. And who knows what we get before Christmas.
Yeah, but I would say generally we did get this one correct. And so on. So we did for the second prediction, which was that there was a lot of talk about how legal and copyright laws and all the fair use of data would stop all these large-scale pre-training that's needed.
Hasn't happened.
Yeah, and we've seen, I think, also some laws from Germany and other countries which try to allow AI to be trained to kind of push this technology forward.
So we were speculating that AMD, based on its revenue predictions, would make a serious dent into NVIDIA's dominance. But apart from some European supercomputers being built on AMD. It hasn't really happened in a broad sense. And actually, we see that other challengers like Cerebras and Grok, and also Amazon's own chipsets and Google's own chipsets have made more of an impact.
Right, but I would say still this does not leave a dent in NVIDIA's earnings. It's still
not
growing.
Really, but still our prediction was not entirely correct. The fourth one was about synthetic data. I think that has pretty much happened, right? Like all of the major models these days are making use of synthetic data to some extent.
Yeah, I would say that at the end of last year, there were a lot of papers on this self-play and reinforcement learning and self-iterating training paradigms. I don't think we've completely followed that track, but for sure, synthetic data is a big factor. And for example, Llama 3, in their technical report, they delve in how much they use synthetic data, generate data from existing data, and so on. So I think it's for sure a large factor in how these models evolve and have gotten better this year.
Text to video, a lot of actual products on the market now, from Kling and Runway.
Yeah.
And Sora still to be released, right?
But yeah, maybe it's one of the 12 days.
It's pretty sure.
But so, I would say
let's count this as a green check.
And I think we're lucky that it's not just closed models. We see a lot of open models, open weight models on Hugging Face where you can use them. Still not to the full kind of high definition that we get from Sora, but still I think it's a very good, promising direction.
So number 6, we thought that some of these kind of humane pin and rabbit devices were going to catch on, or maybe Apple's VR set. Hasn't really happened, right?
Yeah, no, I would say that for sure no one has really delivered something that captivated the market or inspired more to hop on it. I would say even less so. Everyone is trying to avoid that and work with computers or supercomputers even to deliver some convincing result rather than a convenient device that you have.
I think there's still a lot of cardboard boxes sitting on some shelves somewhere. So then we thought that foundational robotics models would be here with us by the end of 2024. What's the consensus in the audience here? Do we have them?
I see a lot of so-and-so too. Probably not.
It's kind of halfway, right?
Yeah.
I mean, there are companies like Physical Intelligence, for example, which have really made big progress in these kind of foundational models, but it's still very much in the lab. It's not, there are no actual models that you can download, which you can just plug into arbitrary embodiment.
Yeah, for sure we don't have a run Llama on your laptop equivalent for robotics. Everyone kind of has to pick what model they work off of and tune it for their data in domain.
And we also thought, number 8, that the sort of train your own GPT or personalize your own GPT, that would be a hit. Not really happened.
Yeah, I think the testament to this is the GPT's system and store that OpenAI had planned is kind of falling off slowly.
And then what do you think of the progress in AI for science? I mean, certainly the Nobel Prize was kind of awarded for this direction, but our prediction was that it will make a real-world impact on material science, pharma. So I think we have a few drug candidates, right, that are actually generated by generative AI methods.
Yeah, but I see a lot of companies that start up in this kind of area of material discovery, drug or protein folding.
Yeah,
and also
Cusp AI
for
here
sure.
in Amsterdam.
Yeah, and also, I mean, Google is pushing for TPUs and also this chip discovery. So I think they have the most to gain out of this technology working out. So I think they will continue investing. So I don't think it's completely falling behind like some other of these points maybe.
And the last one was that really generative AI will start to contribute to real revenue and profit in companies. It's kind of hard to measure, but based on a survey done a few months ago by Deloitte, we see that actually around 70% of the executives from very large companies are investing more in generative AI for next year because of the immediate return on investment that they see from the ongoing experiments. So I would count that as a yes. So what did we miss?
Well, I think there are a few things that no one could have predicted, and some other things that were there, but not to the extent where they've blown up exponentially in the year.
So we had RAG at the beginning of the year, but I would not have predicted that I would be talking to company managers and they would be using the word RAG as a similar way as to Google something. We built a few RAGs for this and that, and yeah, that's definitely the word of the year in enterprise IT, I think. And agents, right?
Agents, yes.
Yeah.
I mean, we could probably see it coming, but I think is the one feature that everyone tries to grab onto and develop systems because it's kind of futuristic sounding, but also it can deliver some pretty impressive results.
And we had, of course, GitHub Copilot at the beginning of the year. But what we did not expect is that around $2 billion would be invested in competitors to GitHub Copilot.
Right. And I would probably even dare to say that who uses Copilot anymore with all these new IDEs that are heavily focused on just code supplementation and agents in for kind of all kind of tasks, but probably mostly in Python and JavaScript, where most of the developers are working with.
And then I went back to January and I looked at our predictions for like GPT-5 and thought it was going to be a really huge, unprecedentedly trillion parameter model, but that hasn't happened either.
Right.
So we actually see the opposite, right?
Yeah, we see a lot of open source models, which obviously cannot train or deploy to that scale because I think most people that are developing open models, they also care about, okay, who am I going to send this model to? I think only NVIDIA is the ones that are putting out models with 500 billion parameters. Everyone else says, okay, I know that you're going to run this on an A100 or H100, so I will only limit it to a small model.
Yeah, but the small models actually have turned out to be quite competitive in terms of parameters. There's quite a lot of models in the sort of single or double billion digit parameter range, which are competing with the initial version of GPT-4, right?
I think it's also a testament from OpenAI itself. I've read an article, I'm not sure how credible it is, but they're claiming that GPT-4, the original one, is the biggest model ever trained. And ever since, even 4 Turbo and 4.0, they keep getting smaller and more efficient, but smarter distillation techniques or better data. So I think it's a paradigm where we're seeing models scaling it to a point and then going back down to make it more efficient.
And also another parameter of scaling has emerged with O1 and similar models. A lot of open source models also now trying to catch up. It's inference time scaling, basically letting the model think longer to reach a higher quality. And the last one?
Yeah, it's one area that is really close to us, and that's I mean, in general, RAG is developing, but people are realizing more complex cases where they need visual information. And for this, called PaLI as a paradigm, or generally vision language models being used as encoding models are being more and more popular.
Yeah, so complete rethinking of the whole document processing pipeline for information retrieval with vision language model as the only encoding layer with PaLI. All right, so we'll be back in January with some new predictions, and I think with a score of 5 out of 10, we still have some improvements to make. We wanted to cover the new Google models with the title "Google Back on Top Again." So obviously, Google has struggled during the year to make their Gemini models competitive. And for this brief moment here, which I captured in this screenshot, their latest Gemini model, it's a preview model kind of, right?
Yeah, EXP stands for experimental, I think.
So it's available in the API, but it's not officially released. I heard rumors that it was going to be officially released today, but it was very short-lived. This is today's ranking, so the difference was very small, but just a few ELO points. And the latest ChatGPT 4.0 is actually back on top. What I find super interesting about this latest ranking is that actually O1 was kind of presented as a big jump in reasoning capabilities and quality of output, but it's just been surpassed by the regular 4.0.
Well, yeah, I think here we're getting into a kind of technical definition of what is better and how is this chatbot arena evaluating the true performance, or which aspect of the performance, because I think here you're not going to ask the same questions that O1 is built for with this mathematical problems, PhD level intelligence. I think most of these users are probably just asking some general question that they know their answer for and just vibe checking the model answers.
Yeah, so you think it's to some extent a question of style.
And benchmark, yeah.
So if we look at what has happened to the large language model providers in terms of market share, this is a really interesting statistic from Menlo Ventures, which measures the market share, I assume in dollars or number of customers. And what we see here is that Anthropic has doubled their market share over the last year, and is very close to catching up with OpenAI. Actually, Google is not doing that bad. It also made a lot of headway, and the one losing market share is really OpenAI this year. And you would think that's at the expense of open source from Meta or Mistral potentially, but it's mainly at the expense of the other closed vendors.
I mean, also the market, the whole development scene is kind of unifying in a way that you can just plug and play any model, and you're obviously going to pick the best one.
Yeah.
So
where we started the year kind of with the saying that the foundational models are the mode, and that all application developers, all these startups developing, business-specific applications on top of them are just thin wrappers. We're ending the year in a situation where it seems like the value is actually in the application layer, and the foundational models themselves are being commoditized. So let's move to other news. There's also a lot of reshuffling of chairs between the large research labs. So I think one of the most interesting ones is Yi Tai, who founded Reka not even 1.5 years ago, right? Built a pretty competitive multimodal model and released it, shipped it, and now he's back at Google.
Yeah, I think he learned the struggles of GPU poor or medium wealth out there, and not having one big cluster and access to compute and developer tooling.
At the same time, other people from Google, all these guys here in the top picture, they went from the Gemini team to Anthropic.
Anthropic, yeah.
Yeah. And then OpenAI poached quite a interesting group from Google.
Google
right?
DeepMind in Zurich, yeah. So Lucas Bayer and I think 2 or 3 other people opened a new chapter in Zurich. I don't think they had offices there, OpenAI. So I think they promised them that they will start something.
The anecdote was that Lucas Bayer said, "I want to continue working in Zurich."
Yeah,
and then
that's the solution.
The OpenAI office was opened kind of for him.
Yeah, and another interesting one is Notebook LM, which had all the hype in the past few months. I think the product lead or one of very influential people from the team decided to leave and start their own company. I can imagine what they'll be working on, but I think all the success with them.
Automating podcast hosts like us. Who knows how the first podcast of the new year will look like. All right. So in other company and startup news, we're seeing a lot of announcements, though, of course, around agents. But in particular, this cluster of announcements caught my eye. Agents with wallets.
So what is it about?
So basically, quite a lot of companies, including some very big ones like Stripe and Coinbase, are developing infrastructure which makes it really easy for developers to do function calls that actually either spend or earn cash in agentic transactional workflows.
So does this mean I'm ready to give up my wallet to GPT or best model?
It could be a crypto wallet, right? That the agent is just making small micropayments for its services and collecting them and then being able to spend them on compute or something like that. or it could just be your credit card, and the agent is actually doing your Christmas shopping for you. Apart from the big ones like Stripe and Coinbase, there was also Skyfire startup, which is actually funded by Coinbase. So a lot of people are going for this new space. In other more noticeable AI startup and funding news, we saw Netherlands-based Cradle, AI-powered protein engineering startup, get serious funding with $73 million. We saw the Writer platform get $200 million of funding, and this here is a huge investment, almost $700 million in AI hardware company Tenstorrent. And a somewhat smaller seed round for another agent startup called Dev Agents.
I wouldn't call it that small for a seed round, but also the people behind it are pretty spectacular. Ex-CTO from Stripe and also Android.
Yeah. So maybe they go for the same agent with wallets space. There's also some exits. Supermaven joined forces with Cursor. I don't know who's sort of the leading party. Is it a marriage of equals?
Yeah, I think Supermaven was more focused on this tab completion plugin, and Cursor obviously invested heavy in the ID, and kind of they want to merge paths because both are seeing the benefit of each other.
And Neural Magic, which is this pretty cool deep learning acceleration platform, doing a lot of things, interesting work in quantization and model training, compression, got acquired by Red Hat, the Linux behemoth. And last but not least, Inflection announced that they're giving up their struggles to make next generation state-of-the-art LLMs. I don't know what they will do now. Probably focus more on enterprise applications.
Oh, we saw that coming, right?
But not all mega startups. I mean, we've discussed here the Inflection saga with the mega round of funding and then the acqui-hire by Microsoft. One similar drama was the company formerly known as Holistic, now called Ash. And Ash from France is back.
They're back, yes, and they released
They shipped, right?
Yeah, the first product. I'm not sure if it's publicly available yet, but it's supposed to be an agent, a language model that takes actions and is actually very competitive for its parameter count, which is, I think, close to 8.
It's a 2 billion parameter model, and it performs better than not only than Anthropic with their computer use module, but also better in many aspects than both Llama and Mistral 8 billion parameter models. So a very competitive model, it seems. And I guess that means they're now the second crown jewel of the Paris AI scene. So let's move to models. What do you have in store?
Right. So this is a fresh release. I think yesterday there was this European French company that released a European model. So let's start with what OpenAI said in the beginning of the year. They said that you need this proprietary data and copyrighted material to create models. Yeah, we do it because we have to create good models. And this French startup Plius tried to tell them, no, you're wrong. So what they did is they trained a series of models around 1 billion and below parameters, which specialize in the European languages mostly. So their mode and kind of claim is that we can do the European language market better, and it is multilingual by design, and it's also heavily engineered, so it runs locally on even CPUs. So
yeah, but I think the main claim here is that it's trained 100% on material which is
copyright free.
Copyright free, right? So how do they know?
Well, I think a lot of the the project is about collecting the data and sourcing it. So they have open sourced all of the data, and they kind of have provenance claims on where the data came from, which data set was it originally, and that it was permissively licensed. And yeah, so from results, I would say that the most impressive one they focused also on was to have adherence to the language where the user asked something. So a lot of models will try to fall back to English if it's some very out of domain question. And the second part is its efficiency in RAG. So they know that RAG is all the hype, so they try to see how well it does in multilingual RAG and how fast it is. So since it is a 1 billion parameter model, we see it punching above its weight, so competing with Llama and Qwen 8 and 7B. But I would say in general, this is a very good release because we see some action from Europe after all.
Yeah, and I was surprised that they managed to actually put together almost 2 trillion tokens of this copyright free data, so of very decent quality. China is also not kind of standing still exactly, right?
Right. Well, I think it all started with DeepSeek, which was pushed from OpenAI to try and replicate this reasoning inference time scaling, and they released R1 Lite preview, some weird name, which indicates that this is just their first try in reasoning. So it's this chat interface that asks you to deeply think about the problem. And I mean, in benchmarks, we see that, they're doing quite well. They compare against O1 preview, and they're right about in the same ballpark, which this launch kind of triggered an avalanche of other models. The most popular one, I would say, is Qwen with questions, or Q, which is how they want to pronounce this new model from Alibaba. I would say it's also very rushed because they claim, first they say so themselves, but also the scores are not quite as competitive as R1, but you can see that there's a lot of activity trying to replicate what these closed models do.
Yeah, and both are open source, right?
Open weight, yes. I think it's the best that we can do with models that are not behind an API. An interesting observation is that they're both from China, and in general, we see a lot of activity in trying to catch up despite all their hardware restrictions.
Well, I think they're getting around that
pretty easily.
But I think they're trained on a lot more Chinese data with a lot more Chinese alignment practices, which is something that can be a concern because they sometimes switch back and forth between English and Chinese, but also because of some of the alignment is actually very close to censorship, right? So the CEO of Hugging Face, Clem, voiced his concerns around these open source models being the foundation for further fine-tuning, because they're really this kind of not wanting to talk about certain topics like the Tiananmen Square or Taiwan or other things like that are deeply baked into the models. We also see that Apple is rolling out their Apple Intelligence in China and actually using Baidu models, Ernie 4, I think. But they're facing some hurdles, especially in terms of quality, it was reported. So beating 01 on the benchmarks and 4.0 on the benchmarks is not yet the same thing as being as good in practice. This is a pretty open model, a lot more than open weights, right?
Right. So Tulu 3 is one of Alan AI's contributions that we got this month. So what it is, we also have it in our paper preview, so we'll dive deeper into it. But in principle, it's just a lot of emphasis on post-training. So we know that models have this pre-training phase where they aggregate a lot of the web data and try to grok as many of them as they can for world knowledge. But then, one of the key ingredients this year has been training the model to get some skills and align with human preferences. So Tulu 3 is this open data set that they collected that is very performant on some key skills like maths and reasoning.
Yeah, so it's sister or brother is Olmo.
Olmo, yeah, because Tulu 3, the final model is fine-tuned on Llama, but Olmo 2 is same data set for post-tuning, but applied on a new generation of Olmo, which is their fully open source, open data, open code, completely open science model.
Yeah, so we see actually in some of the papers that Olmo is already being used to do pretty advanced kind of replications or comparisons with the state of the art in research papers. So good job there for OpenAI. Sora is not yet out, but there's many alternatives.
Right. So I think this week we got this LTXV, which is a real-time, is what they claim, video model. So you can just write something and it will output frames faster than the AI can process. So that gives them some redundancy and some quality benefit because they can have high frame rates. And I also spotted this work from Google, which we had covered previously, Genie 1, which, if you remember, was like a platformer environment where you could go left to right. So it was kind of a demo, but now they scaled it to pretty impressive environments. So it's like completely 3D first-person or third-person views. And they claim that they can run pretty fast.
So it's not exactly video generation, but it actually generates a fully playable game world where the
you can interact with
user action can guide the perspective of the first-person view.
Right, and this aligns kind of with our claim that text to video is going to be huge, and I think we got that right.
In AI for Science, we're going to talk about this in the paper section in a bit, so let's not dwell upon it too much. But Google DeepMind announced an AlphaQubit for error correction in quantum computing systems, and they also, I think, as part of their quest to collect more Nobel Prizes, are able now to predict the weather with a pretty amazing accuracy, up to 15 days in advance.
Right, and pretty efficiently. I think in the next figure we have it, they beat the current kind of standard for weather prediction, and it's quite efficient because it runs on 1 TPU in 8 minutes, while it would take hours in a supercomputer before.
In a physics-based model, and the last one for molecular discovery is the unexpected open sourcing of the AlphaFold
inference. I think
only inference.
I think so. Yeah.
Sorry, we had a small technical glitch. Thanks for waiting for us to recover. Continuing with embeddings news, I think most notable one of this month was Snowflake's Arctic Embed 2, right? A fully multilingual model.
A pretty small model. We're used to this kind of paradigm of 7B models to try and beat the benchmark, but I think they managed to do a pretty good job with just a bird-sized.
Well, it's not entirely there. If you look at the MTAP leaderboard, the top models are scoring around 63, right, on beer. This is a small but very capable multilingual model, and it's open source, so you can use it as the base for fine-tuning. So let's dive into NeurIPS.
Right, so we have NeurIPS next week. Unfortunately, we won't be there, but everyone in Vancouver, I'm sure they're going to have an amazing time. It's 5 days, including the workshop, and 3 keynotes.
4,500 or more papers. Well, that's just the main conference.
Right, and I think it's 2,000 more for workshops. How many?
56 workshops. And I wonder what it's going to be like to actually navigate that. But don't fret, we have a guide for you. Well, first of all, there's kind of the official selection from the conference, going back 10 years, the Test of Time Award.
Right, so it's 2 papers that I'm sure most people in the AI scene, if they've read some papers, these are 2 of them that they must have already seen. So it's the GAN paper, Generative Adversarial Networks, and Sequence-to-Sequence Learning, which are 2 pretty, I mean, I'm not sure about GANs, but for sure influential over the years. And how we're
deservedly won. Goodfellow and Sutskever as first authors. But we also have the full conference content in Zeta Alpha.
Well, we see a lot of clusters, which are the fields that are most prominent in these 4,000 main papers. I would say that it's pretty similar to last year's, which is to be expected from a conference on neural information processing and neuroscience-based kind of audience. So we have a lot of molecular representations and design and time series neural dynamics, which are kind of the NeurIPS special, and all causal algorithms as well. But we see some strong influence from the NLP community starting to creep back in, which is like language models and agents and transformer and attention variants and all that kind of stuff.
So what are your favorites that are definitely not to be missed?
Right. So I think if you're going there, these are my top 10 that I would try and speak to the authors about. Some of them are like the highest scored or reviewed papers, and some others are our picks and some papers that we had covered in previous webinars. One of those is the first, which is called Exploitation of a Latent Mechanism in Graph Contrastive Learning, which is kind of a new breakthrough in how contrastive learning is performed on graphs. They kind of collected existing technologies and tried to find a common way where contrastive learning is trained. We have the Road Less Scheduled, which is a paper on how we can create scheduling-free learning optimization algorithms, which is pretty popular these days. Let's continue with the ones that we had not covered. One is Buffer of Thoughts, which I was pretty sure we had in our runner-ups. Buffer of Thought is kind of a meta-level chain of thought where you can save your previous thoughts and reflect on them while solving a new task. SG-Lang is a framework and also kind of a pipeline how to create structured outputs more efficiently with some theory of computation ideas like finite state machines. Cambrian 1 is a paper kind of focusing on multimodal models from the ground up and vision-centric. So how can we combine modalities, that sort of approach. Then let's go quickly through the papers that we have covered. So if you want to know more about them, we have them in our blog and previous videos. One is Not All Tokens Are What You Need. That kind of claims you just need some tokens that have high loss, and the rest you kind of don't need to train on them. One is Many Shot in Context Learning. People, I think, from Google, along with their Gemini models that say, okay, you really can push the envelope on putting as many examples as you can in the prompts and not just 3 or 5 where the featured learning paradigm was before. We have Humanoid Locomotion as next token prediction. This is an interesting paper, I think, pretty recently we covered on, you can model robotics as motion as just predicting which next token you have to pick from. XLSTM, which is, I think, the third overall most rated paper from NeurIPS, is this new spin on language on LSTMs based on the latest and greatest transformer scaling methods. And which one did we not mention? Flash
Attention 3.
Yeah, which was in 2 months ago. A new way to just be more efficient with the attention operation. All
right. So the other conference which was going on this week was AWS Reinvent, and we saw that Amazon launched their own series of foundational models under the brand Nova. And I think they're pretty competitive, right? They're up there with the Llama 3.2 at least, and kind of a little bit below GPT-4o.
Right, and I think it's mostly the target audience is people that want to have everything in AWS.
And if you have everything in AWS, also this automated reasoning check is pretty interesting service, which checks model outputs for factuality and provides a guardrails framework. And finally, the Anthropic tie-up got even stronger. New $4 billion investment in Anthropic, and an announcement that Anthropic is moving some of their workloads to Trainium, Amazon's own internally developed chipsets. So I think we need to move forward and go to the top 10 papers.
Right, so this is kind of the usual visual representation of the most trending papers of the last 4 weeks.
So what is on?
Yeah, we have a lot of papers on language models, RAG, inference time scaling, some re-ranking and retrieval-oriented insights, and some more general like agent and societal or psychological use of language models.
So given the time, let's dive in. OpenScholar.
Yeah, this is a really nice paper and it's pretty related to stuff we've been working on at Alpha. So OpenScholar is a system that is built for these questions about scientific literature that really need to iterate on the answer and collect many sources and provide citations. So they've built this really nice system which gets to the first results, iterates on the answer, sees what's missing, it expands the horizon, and tries to provide a comprehensive answer with citations. So they trained systems for this, so the language model, the retriever, the re-ranker, and everything, and their components. And I think one of the main innovations in this paper is this benchmark that they both trained and produced as evaluation, which is Scholar QA Bench. It spans many kind of fields. And yeah, their final system is pretty competitive. So it competes against GPT-4o without any retrieval, and even with retrieval, just by applying the system that they have, this agent set up, they can improve. So I think on the next slide, you can see its 8 billion model can match 4o with no retrieval. And just by applying this refinement methodology, it can improve the base model by 12% in answer correctness and also citations. So they find that it hallucinates where it puts citations or which documents it picks. And this method just improves that to make it more reliable to use.
Right. So number 2 is an application of a fairly obscure method, which you cannot do with commercially available large language models. So you need access to the weights. And the idea is to do test time training. And it's applied to the ARC challenge. If you remember, the ARC challenge is a series of small visual kind of analogical reasoning like puzzles, which have until now proved to be very hard for large language models. Large language models, even O1 preview, only get about 20% of the puzzles right. And so you can, for those of you who know ARC, for each puzzle, you have a very small amount of training examples, maybe just 3 or 5 examples. And then you have to extrapolate from that on the test instances. So what this team from MIT has done is apply this test time training, where basically you take this very small amount of training examples and you fine-tune just a little bit using an adapter before doing the test examples. And that doesn't seem to work very well with just a few examples. So what they do is they make a whole bunch of synthetic data out of these few examples. So they apply all kinds of transformations to these examples to generate a set of maybe a couple of dozen examples, and then train on them. And then they actually end up doing a whole lot better. And they end up beating the average human score, which is 62% of the ARC puzzles. So that's a huge advancement over the previous state of the art. I think we'll see more papers like this, because actually today is the deadline for the ARC challenge. So there'll be a lot more submissions, and I'm really curious whether this paper will make it to win the prize, $1 million, I think, right?
Yep.
But the prize is for those beating
the best human,
which still does about 97%. So we're still a bit off. Tulu 3.
Yeah, so this is the model that we previously covered. So let's have a bit more detailed view of how they did it. So the pipeline is pretty simple. So it's the typical stage of instruction fine-tuning, followed by some reinforcement learning based on human preferences, like DPO. And then Tulu specifically introduces this new phase, which is, my understanding is that they want to improve these difficult tasks like math and coding and reasoning, where previously models like Qwen or others did not get so good results on. And they do this by introducing what they call reinforcement learning from verifiable rewards, which means that they only give a reward to the model if it correctly gets the full answer and not just a preference between 2 outputs. And you can do this, as you can imagine, in problems where you have the real answer, or you can verify what the model outputs. And another trick that they use, which is pretty interesting, is there's splitting of development and test evals. So they take some of these data sets that are commonly evaluated on to kind of monitor their changes in the training data, in the training distribution, and the 3 different phases as they're doing it, and then just finally produce a model and test on the unseen tests, which are pretty similar data sets, but not the same. So on the results, we see that it surpasses the original fine-tuning from Meta. So they take base llama and completely beat the instruct variant, but also kind of match the performance of other notoriously good models like Qwen 2.5. So I think it's a good model, and I think a testament to this is how they just took this data set and applied it on Olmo and completely beat everything else, even though it's completely open source.
All right, so this is a somewhat Amsterdam-based paper. Dirk Kungma contributed to it in between jobs while he was applying at Anthropic. So this is a joint paper with people from
News
Research, the sort of open source hacker collective. And it's kind of aimed at those people who don't have a supercomputer, but want to train a very large language model on a loosely connected network of volunteer computers, kind of distributed training across the internet. And the problem is that you have a lot of GPUs, but you don't have very good communication between them. And in normal kind of Atom optimizer, you need to exchange gradients between the GPUs at a massive rate. So what Peng and Qwen and Kingma did in this paper is actually make some assumptions about the momentum, sort of the general directionality in which the training is going over many steps, and leave out the exact transmission of the gradients. So basically, there's a bunch of estimation tricks of what are kind of the main components of the momentum and what are kind of noisy local directions of the gradients, and only this sort of more general direction is transmitted across the network. And in this table here, you see that this leads to like 2 orders of magnitude on some cases of less communication over the network. And interestingly, it actually works better than with the full communication. So this new demo optimizer actually beats AtomW on Olmo. So it was tested on the Olmo LLM setup. And there's almost no compute and memory overhead either. So pretty neat new trick.
Right, and I think this week they just published this distro model, which was trained exactly on this kind of distributed setup across continents. It's pretty impressive.
So this is a information retrieval paper, which caused quite some stir, right?
Yeah, I think it's kind of provocative. Its main claim is that re-rankers are not that good at re-ranking the full data set. So what they find is that as you scale the number of documents you re-rank up until a normal point, like 100 documents, you get the performance benefits. But then as you grow to 1,000 or 10,000 documents, up to like the full collection, so using a re-ranker as a first stage ranker, then you kind of see anomalies where the re-ranker will give a high score for documents that have no lexical or semantic overlap. And yeah, so they show this with a bunch of data sets, both academic and internal enterprise data sets. Mm-hmm. And they propose that list-wise re-ranking with a sliding window, like we've seen with Zephyr and GPT-4o, this kind of works better. And I mean, I see the point, but at the same time, these models have not been trained for that. And they realize and they acknowledge that this is probably because re-rankers are trained to just see a first stage result list and only boost those.
But it's kind of conflicting with traditional wisdom that you can just increase the size of the first stage retrieval and just apply a very powerful re-ranker. But then I think you've forgotten that there's such a thing as false positives, which eventually will work against you, right? I think that's what we're seeing in this graph.
And I think this is like a cautionary tale because people just think, oh, I can just increase K and I'll get better performance. But in reality, no, you have to check per data set what is the optimal. Yeah. This is what the main argument is for.
All right. So the next, given the time, the next paper we'll just mention very briefly. So we already talked about it in the news section. AlphaQubit, another sort of AI for science, big team effort by Google DeepMind together with the Google Quantum Computing division. They basically were the first ones to use transformers to train specific models for denoising. So quantum computation suffers a lot from actual physical noise in the physical quantum bits, and they developed this system which beats the state of the art by a pretty big margin to filter out this noise in practice. However, it doesn't really have impact on quantum computing yet, because it's an order or two of magnitude too slow to actually be used in quantum computers yet. So what about this one?
Yeah,
M3
it's M3 docrag. It's a complex acronym, and we can break it down to M3 doc, which means multimodal, multi-page, multi-documents. And drag is, as we know, retrieval augmented generation. So this is more of a benchmark paper. They test how well the Scolpali plus VLM paradigm works for document understanding, where the answer is not in one page, because as we remember, Scolpali emphasized mostly on this. You have one page of visual information. How well can you find the right page? Well, here they just have a benchmark where they try different questions that need multiple pages. So it's an true open retrieval task where you don't know which document you're asking the question for. And yeah, I mean, the main takeaway is that, yes, Scolpali plus a VLM like Qwen 2 works. And they do some experiments on how fast it is. And they find that using an inverted index like IVF with FIS, it works most optimally in terms of having an actual fast retrieval.
And the results to prove that from the tables. So this paper is caused a lot of stir on Twitter. It's actually a fairly shallow paper, but it's a very interesting idea. So can you do kind of more traditional societal research that is traditionally done using questionnaires, right? You ask a lot of people stratified samples for, I don't know, what they're going to vote, or what they think of a product, or how they would react to a certain type of change or innovation. And that's been traditionally very hard and costly. And what they do in this paper from Stanford is just make LLM-based simulations of a lot of people by conducting a lengthy interview with those people and just putting that in the prompt. And
so
that's
they're building
That's
a profile just from the
Yeah.
question answering.
Yeah, so just transcript of 2 hours of interview, and they show that this works a lot better in predicting participant score on all kinds of questionnaires than traditional sort of demographic or persona-based models.
Okay, so we have another retrieval-oriented paper, or rather ranking paper. So we have this LLM as a judge paradigm where everyone is using ELO mostly for solving the scores and the capabilities of each model. And this paper takes a more deep dive into the actual scoring mechanism or algorithm. And they find that ELO is actually not the best one. So it has this assumption that from chess that you have the stable outcome every time, but that's not always the case. So they investigate 2 other popular algorithms like Bradley-Terry and Glico, which are modifications or different approaches to candidate scoring. And they find that for large data sets and uneven data sets, they have kind of an edge over ELO. It's a really good paper, and I really suggest you read if you are into this evaluation system design.
Yeah, so soon we will not only have Reg ELO, but Reg Bradley-Terry and Reg Glico.
Glico runs nice on the tongue. I think it's good.
All right. And the last paper is kind of a novelty paper, a fun paper, but it's kind of very interesting read. This super weight in large language model, work done by Apple and some student from Notre Dame University, shows that in very large language model, many billions of parameters, you tend to have these very small amount of weights, usually just one or a few, which if you perturb that single weight, the whole network will start breaking down and will no longer produce coherent text. So out of 1 billion parameters, you erase one, and the network will start producing complete gibberish. Well, if you want to know why, you need to read this paper. But the basic intuition that other authors have formulated was that this was some kind of bias term. So, right, you have kind of a linear classifier with a bias term, and that this was doing that. But it turns out that in this paper, they discover a more, this, by the way, this table here shows you the exact addresses of these superweights in popular models like Llama, Mistral, and Olmo and Phi. So it's really like a very specific street address where that weight lives. And here you see that if you kill that weight, the perplexity on common benchmark like C4 and Wiki2 will completely explode. And the hypothesis which they defend in this paper is that it's actually not a some kind of general bias term, that that is the learning of the network to suppress function words, stop words. So that basically, if you remove this term, the model goes back to kind of modeling the probability of the next word and not the semantics of the whole sequence. And they show this in a series of clever experiments. So yeah, check out superweights. And that's the end of our show. With a few technical glitches, we've made it to the end. Thanks for your patience for that. I think it's a wrap for this year and for our show, but also for deep learning in general, according to this tweet from Francois Fleuret. And the reason he gives is that the MNIST database is no longer available.
On Jan's website.
On Jan's website, if you click the link, you will have a permission denied error to download MNIST. So conspiracy theorists could think that this has something to do with the Jan's changed stance towards open source models for the new year. Who knows? So that's it. Thanks for joining here. Thanks for joining online. We'll be back in the new year with a new show, and we wish you happy holidays.
And we'll see you at January with some more hot predictions.
Yes, and the QR code here, you can sign up for the next show. And in the meantime, enjoy discovery with Zeta Alpha.
Thank you.